Hello, I'd like to solve this problem here for you. This is from chapter 2, 2.2, I guess number 15. Okay, so it says graph the parabola and give its vertex, axis, x-intercepts, and y-intercepts. Okay, so let's do all this. All right, so here we go. So what we need to do is complete the square. So I'll do that here. So first we write down what we have here. So y is negative 2x squared minus 20x. All right. So this is what I like to do. Get rid of the coefficient. I'll work inside of the parentheses here. Oops. A little error there. Like that. Okay, now to complete the square, we know that we need 2 times h has to be 10. In other words, I'm trying to find out what h is. So h is 5, and h squared has to be 25. Okay, what I'm looking at here is we have this expression that x plus h squared is x squared plus 2hx plus h squared. I'm trying to use this fact when I complete the square. So based upon that, looking at this 10 in front of the x here, tells me that my h squared has to be 25. So I rewrite y this way. So I need that to find a 25. So I'll just put plus 25, and then to make sure that I don't change y, I have to clearly subtract 1, because I want that to be 24. Okay, now using our formula for the perfect square, we see that we get negative 2 times, there's a little bit here, so it's x plus 5 squared minus 1. And now if I multiply the minus 2 through, I see that I get my final answer. Well, at least I've rewritten my quadratic so that I can see what the vertex is. Okay, so the vertex v that they're asking for would be the point minus 5 and 2. That's the bottom of this parabola, or the top in this case of this parabola. Because of the negative 2, it's actually going to be going downward. Okay, now I need to find out, let's find out where this is actually 0. Okay, well, let's find out, let's plug in x equals 0, so I need to know that anyway. So if, okay, so if x is 0, then we see that we have y is equal to negative 2 times 5 squared plus 2, and that's equal to negative 50 plus 2, so that's a negative 48. Okay, so this is our, let's see, if x is 0, this must be our y-intercept. Y equals negative 48. Okay, now to find the x-intercepts, we would just try to solve what? Well, we have to solve. We want to find out when negative 2 times x plus 5 squared plus 2, we want to know when that's 0. Okay, so then if I subtract 2 from both sides and divide by 2, negative 2, I get x plus 5 squared has to be equal to 1. Now taking the square root of both sides, I see x plus 5 is equal to plus or minus 1. Okay, and now if I subtract 5 from both sides, I see that x is equal to plus or minus 1 minus 5. So here are my two roots, or my two x-intercepts. I get one at x equals minus 4 and one, or x is equal to minus 6. Now I want to drag this in here to show you how you check that. I mean, the bottom line is what? Well, let's make sure that we get 0. So I dragged out my little magic thing here. Notice that if I put a negative 4 in here, I think minus 2 times a negative 4 squared minus 20 times negative 4 minus 48. Notice I get 0. Also, so that's good. That means I did something right there. Put a 6 there. In other words, if I evaluate at negative 6, I also see that I get 0. So that's a check. The bottom line is whether it works or not. So I must have done something right. All right, now let's graph this thing. Okay, so here I'm going to graph this, we need to put, place the vertex. I know on your, so here's some coordinate system here. I know in the software they provide a lot of these things. So let's recall here. So we got our vertex here is at the point minus 5, 2. So let's just make a little thing there. I guess it's right here. I don't know. Minus 5, 2. Okay. Let's see. Claims here x equals minus 4. There's a point here. It's pretty ugly here. A point here. There's my x-intercepts. So this thing would go like this, right? It's a parabola, so it pops down like that. Whoa, horrible picture. And then it. See, this is not very good. A parabola looks like this. So I think this is. I'm drawing with this pad, so it's going to look like this. I'll shift that over there. It comes in there. Anyway, I think you get the point. And the y-intercept here is at the point 0. And what did we calculate? Minus 48. So the scale is way off, but the idea is all correct. And finding these points is really illustrated above here. So I hope that this helps you out.